at this polynomial equation here, which has a sum of two perfect squares. So we can take advantage of factoring this, just like we would with the difference of squares. We can factor a sum of squares using the imaginary unit I. So we'll go ahead and factor this as x and x. And then, just like with the difference of squares, if this had been x squared minus 16, we would say plus 4 and minus 4 to factor this. Being a sum of squares, we use the imaginary unit I, so we'll say plus 4i and minus 4i to have that factored. There's another video that I made referencing how to factor a sum of squares using the imaginary unit I if you need to review that. But that's what we're doing there. And then we can again use the zero product property, just setting each of these factors equal to 0. So we say x plus 4i equals 0 and x minus 4i equals 0. And you can solve each one of these in one step of algebra. Subtracting 4i on both sides, you'll get x equals negative 4i from that factor. And then adding 4i on both sides, you'll get x equals positive 4i from that factor. Which, if you want, you can go ahead and write those solutions together as x equals plus or minus 4i. And that's how you do that. Take a look at this one on your own. Try to work it out. See how you do. Check it against my solution on the next slide. Notice that this is a difference of squares instead of a sum of squares, like in the last example. So you will not need an I on your factors for this. Difference of squares will not need the imaginary unit I like some of the squares did. So take a look at this one and see what you can do.